Hello, welcome back to Hudson Valley Community College QBA. This video will be your first video on compound interest. So I hope you first of all made a copy or printed out a copy of the handout. I'll show you that. And also you need to go through the PowerPoint presentations. Again, I will only cover some topics. I will not cover every single problem. And you need to review all the different problems and how to record them. So I would like to, first of all, go over to what the handout looks like. Compound interest. This first compound interest formula, future value equals present value times the quantity 1 plus I, close parentheses, raised to the n. So there's two new variables here, I and n. Let's start with n, that's the easiest. N is the number of total periods in the compounding, and I is the interest per period. So we'll practice that a little bit, and I'll show you how to do it. But let's go through here. Compound annual interest. If I say it's compounded semi-annually, that means it's twice a year the interest will be added on to the principal. If I say quarterly, it's 4 times a year, or every 3 months. Monthly is 12 times a year, and daily will be 365, or if it happens to be a leap year, yes, it will be 366. To find I, let's assume that the problem says it's compounded annually and the nominal rate or the yearly rate is 8%. So in order to do this, it would be 0.08 divided by 1. If it's semi-annually, it's 0.08 divided by the 2 times a year. If it's quarterly, it's 0.08 divided by 4. Monthly, 0.08 divided by 12. And the last one, daily, we'll be working with 0.08 divided by 365. As I mentioned, in the book they do sometimes do leap year. I will not do any problems with leap year or any test problems with leap year. So you can see that these I can be a very small number. In fact, I recommend when you are doing daily, you go to 6 or 7 decimal places. I prefer that you leave something like this in the calculator, right there in the formula. But if you need to write it down and insert it in the problem later, at least go to 6 or 7 decimal places. Okay? So here is your handout. I'm going to go over to PowerPoint now, and let's talk about what compounding is. So in simple interest, if we invested $100 today at 5% for 4 years, okay, it would be 100 times 0.05 times 4, or we'd have interest of $100 or $20 for a total future value of $120. If it's something like a CD and we take it out on the second year, very often you'll only get your $100 back, not even any interest. You get the interest and the principal at the end of the term. Little different for compounding. Compounding interest, at the end of the first year here, you've generated 1 year of interest, or 5%, So at the end of the first year, you have $105. The other thing nice about compounding interest is from between year 1 and 2, you have a new principal of 105, not the 100. You've added on the interest. So you use that in the formula for one more year, and now you have $110.25 at the end of 2 years. For the next year, between 2 and 3, you use the $110.25 as the new principal. And at the end of the third year, you have $115.76. Between the third and fourth year, you use $115.76 as your principal, and you end up on your fourth year $121.55 versus simple interest was only $120. So here's the principal after the first year. Here's the future value or the principal after the second year, the principal after the third, and here's your final value. Now I'd like you to pause for a second, and I would like you to copy this link into your browser and listen to this video. It's like a 2-minute video, and it just gives you an idea of compound interest. So we're back here, and you can see we did these problems on the handout, and you can see that this is a very, very small number. I would actually recommend you go to 6 or 7 decimal places here. One other point I wanted to make, in the textbook, if they do not say it's compounded semi-annually, they don't say compounded quarterly, what they do in a problem is they put it in parentheses how many times a year is compounded. So this would represent semi-annually, quarterly, monthly, and daily. I'm going to jump over this. You can slow it down. So we're going to talk about N now. I is pretty easy to calculate. I just divided by the number of periods. N is a little more tricky. N is the total number of periods. So, for an example, if you're compounded quarterly for 5 years, what are the total number of periods? Well, you have 4 every year. 4 times 5, N would be 20 periods. That would be your exponent in your compounding. If you're compounded semi-annually, from January 1st to 2004 to June 30th, 2010, the best way to do it is go whole years. So you would go January 1st, 2004 to January 1st, 2010, right here. So 10 minus 4 is 6 years. 6 years, I said it's semi-annual, so that's 2 periods. 2 times 6 is 12 periods, but we have one more period from January 1st, 2010 to June 30th, 2010. There's one more period. So we have a total of 13 periods. N equals 13. That's for compounded semi-annually from January 1st, 2004 to June 30th, 2010. And I'll give you a minute. Find N for if this example up here was compounded quarterly. Quarterly, it would be 6 times 4 times a year. That's 24. And then I have 2 quarters from January 1st to June 30th. So I have 24 plus 2 or 26. I'll let you do monthly. Okay, let's do number 4. On July 10th, 2003, $7,500 was invested in a fund paying 8% compounded quarterly. How much is in the account on October 10th? Well, if you notice, this is nice, July 10th to October 10th. So it's even quarters. But we're going to go back to July 10th, 2006, so we can count even years. July 10th, 2003 to July 10th, 2006 is 3 years. 6 minus 3 is 3 years. I said it's quarterly, so you multiply it by 4. Three times 4 is 12. And then there is one more quarter from July 10th, 2006 to October 10th, 2006. Remember, a quarter is only made up of 3 months. 3 months equals 1 quarter. I added on for a total number of periods of 13. In this problem, I'm going to give you a second to find I. Change it to a decimal, divided by 4.02, comes out to a nice even number. So now let's do write down your formula, your compound interest formula now. Be careful, anytime compound interest, we're looking at this formula. Substitute in N, I, and your present value of 7,500 and solve. Please pause the video and calculate. So our answer is $9,702.05. Okay, you invest $100, 5% semi-annually for 4 years. Compounded, there's your compounded formula. The first thing you do when a problem says compound interest, you find I and N. So go ahead and do that. N, 2 periods, 2 per year, times 4 is 8. I is 0.05 divided by 2, 0.025. Substituting it in the formula, 121.84. And that's what we got before. When we do it compounded annually, our I and our N are going to change. N is 4, I is 5. I know I'm going quickly. I would strongly suggest you pause and calculate N and I and the future value by yourself. 121.55. Now, if I did it daily, looking at these two amounts, do you think my future value is going to be more or less than these two? Annual or semi-annual? We're going to compound daily now. It should be more. So pause the video, calculate N and I and the future value. Answer 120. Here's N, here's I. I prefer you leave it in the formula rather than writing in a decimal. There's your exponent, 122.14, a little bit more than the other two situations. There's a homework. There's another problem you can solve by yourself. By the way, we're up to section 3.2 in your textbook. Here's another problem. I'd like you to pause the video, calculate N and I, and substitute it in. In this problem, we've more than doubled our future value. We went from 10,000 to over 20,000 because it's compounding. if we do the simple interest formula here, you'll see over the 15 years we have 17,500. Very different from just compounding annually. Now, here is when we find the future value. I would like to take this formula and solve for present value, because very often we know the future value. I know I want $5,000 in a year to pay for Hudson Valley. I know I am going to have to pay off my car to my parents in the future. So we want to solve this formula for present value. Present value is future value divided by 1 plus IN. So you're welcome to use that formula. At this point, I also like to expose you to this. We've taken this denominator and put it back in the numerator and just added a negative exponent. This is how you'll see it written in the book and on the problems you do in the back of the book, solve for homework. And they've switched present value to P and future value to S. And from the last chapter, you know that's true. Sometimes, like we did in simple interest, we're looking for I, the interest rate. I equals the future value divided by present value raised to 1 divided by n minus 1. Now, when I ask you to find I, you need to go to another step. You will not give me an answer for I. I would like you to change it back to the annual interest rate. Okay? Here's the formula for solving for n, total number of periods. Log, future value minus present value divided by log 1 plus I. When you get n, you do not leave the answer as n. You've got to divide by the number of periods per year. You don't say, oh, I have 6 more periods to pay off my car. No, you might say a year and a half. Okay? So I'm going to flip over to the dock camera, and we're going to look at I. If I get an I of, let's see, dock. Oh, sorry about that. Give it a second here. So here we are. And I said I did a calculation, that formula, and I found out I was 0.01. If I say that the problem was semi-annual, I wouldn't leave it in that form. I would say 0.01 times 2, or an annual rate of 2%. If I said, if I got a problem and I solved for it and I was 0.01, and I said it was quarterly, 0.01 times 4, or 4% annual interest rate, and let's just do monthly, 0.01 times 12, 12% annual interest rate. This is how I would like to see an answer on a test. Don't leave it as I equals 0.1. You will get it wrong. Now let's look at n. If I solve for n, and I got it to be 36. If I said it was semi-annual, I would take 36 divided by 2, or 18 years. if I said it was quarterly, if I did a problem and I got n equals 36, I would 36 divided by 4, or 9 years. Monthly, 36 divided by 12, 3 years. We will do more difficult problems. You might get n 38. And then I say it's monthly. So 38 divided by 12, you have 3, but you have 2 months left over. 3 years and 2 months. So we're going to get a little bit more difficult when we're solving for n. Let's go back. Here is, you can pause this, and this talks a little bit about the log because we will be using logs. Now in compound interest, discounting or proceeds is a little bit different. And it's easier because there isn't a set of discounting formulas. If we want to find the proceeds formula, we use the present value formulas. Remember, a couple of minutes ago I showed you there's 2 of them. In discounting, you usually know the future value and you want to know the present value. So both of these formulas will give you the present value. Let's do an example, number 8. How much should be invested today at 7% compounded quarterly in order to meet a $22,650 obligation due in 42 months? Ooh, I want you to pause. You need to solve for I and N. There is the present value or proceeds formula, I and N. I is 7% divided by 4 quarters, or 0.0175. Look carefully here. N is 42 months divided by 3. There's 3 months in a quarter, not 4. So we had N equals 14. Those of you that put 4 there, remember, quarters are made up of 3 months. We substituted in the formula, and I chose this formula right here with the negative exponent. Remember, when you put this in the formula and you raise it to a negative exponent, you need to hit the change sign key, not the negative. So today, I have to invest $17,765.86 in order to pay off an obligation of $22,650 in 42 months at 7% interest rate. So I am going to, again, I want you to pause here. I have some givens. I want you to solve for I and N. Calculate the future value, but I want you to use all 4 different formulas, the one for future value, I, N, and present value. But then I also want you to go back and use the formulas that I just gave you to, if you're looking for I, if you're looking for N. And remember, compound discount, it's the future value minus the present value, and in this case, $48.31. And here's more homework for you to do. I'm going to go back here. I think I'm going to stop here on this slide, question 9, and we'll continue with this in the next video. Thank you for your time. If you have any questions, email me.